it's very cold and it's a lot of snow, especially during the winter time, of course. But let me tell you, we have had, close to no snow so far yet, and it has been raining incredibly much this year. So I don't know if that's just a seasonal or just this year, if that's something special, but more generally, we have gotten a little bit, less snow all the time and more rain, it seems like,
Yeah, which I think is going to be quite beneficial to both mankind and nature. Yes, there are certain plants that need to go through a cold period to what we call harden off and to set their chemistry, as it were, so that they can then bud out and flower and so forth in the spring. But we're always going to have enough cold. That's not going to be a major issue. A lot of people are concerned that we're going to see a radical change to the point where plants are not going to be able to adapt to the warmer temperatures. I don't think that's going to be the case. As an ecosystem ecologist, we have plants that are always in a state of flux in their ranges and so forth, both north and south.
Sure.
And we have historically, for instance, the polar bears. That's another classic example. Many concerns about the polar bears becoming extinct because of the lack of ice. Well, first of all, the lack of ice in the North Sea or in the North Pole area, Arctic area, is not necessarily caused by the warming, but by changes in ocean currents, and as well as a change in wind pattern for the last couple of years, and it seems to be reversing itself now. That aside, having said that, there's been 6 times in the last 8,000 years, 10,000 years, where it's been as much as 2 degrees warmer than it is right now on planet Earth, as much as 2 degrees, sometimes 3 degrees.
Mm-hmm.
And some of those times we had very sharp temperature changes over a 100-year period, so you're even more sharply than we're seeing today. And the polar bears did fine then, the plants did fine. Yes, they gradually moved north as it became warmer, or as it became cooler, they started to move south over a period of time. But the fact is that it's very unlikely that we're going to see any major extinction phenomena because of the increased warming.
Fascinating. And, one thing that Gore talks about is if we were to look at Greenland, that the ice layer there, and he says that a lot of ice is, falling off, so to speak, at the edges. But you brought out a very interesting piece of information in your film here that is about the two, let's see here, how many planes was it? I guess 8 or something in total. Tell us about those planes that went down on Greenland.
Well, it's a fascinating story. When during World War II, the United States were sending planes over to England, and they sent a squadron of P-38s as well as 2 B-17 bombers. They landed in Greenland, refueled, and were going to Iceland, where they were going to refuel and then finally go to England. Well, when they got to Iceland, it was fogged in and they couldn't land, so they had to turn around and try to go back to Greenland. But when they went back to Greenland, it too was fogged in, and they could not land there either. So they ran out of fuel, or were going to run out of fuel, and they finally decided they were going to land on the ice field not too far from the edge of the southwest corner of Greenland. And they landed. The pilots all survived, and they were picked up about a week later, and everybody survived. It was fine. A team went out in 1982 and tried to find those planes. They figured they would be 10 to 15 feet below the ice surface and so forth. What they found is that those planes were 262 feet below the ice surface. That much ice had accumulated on those planes since 1942 in that 50-year period. And what we're seeing today is that most of the interior ice of Greenland is increasing, still increasing. There are some that is decreasing, but most of the ice is still increasing. It's along the edges of Greenland where you're seeing the major melting occur.
Sure.
But remember, back in the medieval optimum that we talked about earlier in the show, it was much warmer than it is right now. That's when the Vikings actually colonized Greenland. And Greenland then actually was supporting crop growing and so forth. Those along the edges of Greenland is where the ice is melting now, which is exactly what you would expect to see if we're actually warming and recovering from the little ice age. It's not happening in the middle of the Greenland ice sheet. It's happening along the edges where the Vikings at one time had colonized Greenland.
Fascinating, absolutely fascinating. And one thing here also is to point out, I guess, is that much of the science that we do get at this point actually is from computer models. They're running tests after tests, so to speak, on okay, what will happen. They're trying to predict how bad it will get if this continues and so forth. But still, I mean, this is computer models, and they can't add up, so to speak, to the reality of how the climate actually works, right?
No, it can't, and this is a tragic thing. These scientists that are trying to do this modeling are basically good scientists. I mean, that's true with many of them. The problem is that the climate process of Earth is so utterly complex that there's no way that even supercomputers can even begin to approach handling all of the variables involved in climate activity. In fact, one of the modelers actually said this past year that at best they can account for only 1/2 of the variables that go into climate modeling. The rest of them they do not know. And as a consequence, you have 50% of all the variables that can control climate that are not known. Those are all thrown into a black box. What do I mean by that? It means is that this is the way the climate has happened in the past, and we have modeled that, and that way that's what should happen in the future. But it's a black box. They don't know if it's accurate or not accurate, and
Sure.
as a consequence, when they try to actually predict what's happened with a starting point back, say, 100 years ago, those models ultimately fail unless they're tweaked to include all the changes and so forth of that last 100 years. And you cannot hope to project another 100 years to see what was going to happen. But there is a major flaw in the models that was uncovered in 2007 that I think the listening audience ought to be aware of. In every single case, the models assume that the greatest warming is going to occur in the mid-troposphere, up to about 10,000, 12,000 feet. That's where the carbon dioxide is, and that's where the warming should be occurring. The problem is that it does not. And as a consequence, the models are making the wrong assumption that the warming is occurring there, and therefore, since they're making the wrong assumptions in that regard, there's no way they can really predict what's going to happen with increasing carbon dioxide. There is another phenomenon, that is that if you look at carbon dioxide as a greenhouse gas, its ability to, as a greenhouse gas diminishes with higher concentrations. So what that means is that the first shot of carbon dioxide is very, very significant in its respect to greenhouse gas behavior. But the next shot of greenhouse gases becomes less effective, and so on and so forth. So as you get up to 300 to 400 parts per million, its efficacy as a greenhouse gases diminishes very sharply to the point where it's almost trivial. Now, the computer models know this. The modelers know this, and have built it right into the computer models. So it's not the greenhouse gases themselves that's causing the warming at that point. It's what the greenhouse gases they project are going to do. And one of the things that they project they were going to do is to increase more cirrus cloud formations. Those are the high elevation clouds. They're the very thin ones that usually precede a storm. If you see a very high, thin, cloudy layer, you know that you're liable to have a stormy pattern within the next 48 hours or so. And those high, thin cirrus clouds, what they do is they allow quite a bit of solar radiation to hit the Earth's surface and cause the warming. And then when the Earth re-radiates its temperature, the heat back out into the atmosphere in infrared wavelengths, that same cirrus cloud formation traps it. It becomes very efficient. You remember we talked about water vapor being a very effective greenhouse gas. Well, one of the most effective ones is these cirrus clouds formations where you have these little ice particles. And that's what all the models are based upon, is that with increasing carbon dioxide, you get more cirrus cloud formation and therefore much more heat trapped in the Earth's atmosphere. That's what's causing this 2 to 4 degree Celsius increase in temperature projections that the IPCC has been making over the last 15 years. Well, a study was done 2 years ago that showed that this may not be happening. Another study was done and released just this fall, which verified that study of 2 years ago, which was done by Roy Spencer, who was an atmospheric physicist that runs basically runs the effort, or has been. He's changed jobs, but he used to work on the satellite station and so forth, satellite data information. He
Okay.
did a study, and along with several others, that basically show that the cirrus cloud formation is not occurring.
Hmm.
It's not occurring. Not only is the Earth not warming up at the mid-troposphere levels, but this cirrus cloud formation is not forming, and those are the two basic things that these models use to project the increased warming into the future. And they say that as much, if they're true, if further research proves them out, that the cirrus cloud formation is not occurring, that the Earth is not, the atmosphere is not warming in the mid-troposphere as faster than the surface is. If those two things are borne out, when every evidence suggests that they're exactly right, then the amount of warming that we should be expecting should be reduced by at least 75%.
Oops, that's a lot.
A huge amount.
That's a huge amount. You're right. Huh. So it could be thrown off, basically, then the entire thing, so to speak.
Again, it's not that these computer modelers and so forth, they're trying to do their very best, but the very best is it is so far off the mark that it should not be used for anything other than trends and kind of wondering what's going on in the future.
Well,
it certainly shouldn't be used for developing international policy.
Sure, absolutely. And, one thing also in regards to predicting and working with different variables in regards to computer models and so forth. We have the stuff about the volcanoes, of course. I mean, there is certain scientific evidence that seems to suggest that even the sun could potentially affect, volcanic eruption, things like this. This means that if we were to have a period of a lot of volcanic activity or not so much volcanic activity, this again could totally throw the equations, to the left and to the right, so to speak.
Absolutely. The natural processes of Earth, volcanic activity, even when you have major earthquakes that put tremendous amount of dust into the atmosphere, all those have an effect on climate for a number of years.
Yeah.
When Mount Pinatubo blew its stack, and I think it was 1992 or back in the early 1990s, whenever, we had a very cool couple of years following that because of the amount of particulate matter in the atmosphere that was blocking the sun.
Yeah, exactly. So, I mean, let's talk a little bit about the potential positive effects on CO2. You mentioned it a little bit before, but could it be that we're could enter into something completely new, meaning that certain areas that today are very dry or don't have soil to grow food and so forth, that this could actually be better or increase in regards to what I just mentioned there?
It very definitely can. And I just want to mention that if you want to see a 5-minute trailer of the video that we're talking about, you can find it on warmingdvd.com. That's warmingdvd.com or globalwarminglobalgovernance.com, either one. You can actually see a 5-minute trailer about what we're talking about. And one of the things that I do talk about in that 5-minute trailer is the effect of carbon dioxide. I think it's probably true in Europe as well as the United States that most high school or upper grade level in their educational process goes into the importance of carbon dioxide as a food for plants. In other words, carbon dioxide is the main food for plants. It absorbs, plants absorb carbon dioxide, they turn it into food material for themselves, and then when they burn it off and so forth, they emit in the process, I should say, oxygen that we need. So it's a cycle. We give off carbon dioxide, plants use carbon dioxide and give off oxygen that we then use. Well, it turns out that if you go back in history, that carbon dioxide levels millions of years ago were at least 10 times what they are right now in our atmosphere. Much, much higher than what we see today in our atmosphere. And as a consequence, as plants evolved or were created, depending on your viewpoint, those plants were created or evolved at a time when you had much higher levels of carbon dioxide, which means that carbon dioxide today is limiting to those plants. And as every increase in carbon dioxide that you have an increase in plant productivity. In fact, there has been a lot of research, thousands and thousands of research projects done around the world over the last 15 or 20 years that show a doubling of carbon dioxide levels will increase the world's food production by as much as 25 to 50%. A huge increase in food production.